Today we're going to be looking at algebraic fractions some more. We're going to be looking at how we can simplify them, along with how we can multiply and divide them. Before we get into doing actual algebraic fractions, I just wanted to get you to consider a couple of fractions that we've got here that are partially through calculating them. So for example, we've got 1 plus 3 over 9. Now we know that would be 4 over 9. But some people get a bit confused about how to cancel down fractions when there's addition involved or subtraction. So some people might incorrectly think, so let's put a little incorrect here, well, we've got 1 plus 3 over 9. Surely I could cancel off the 3 and the 9 here. 3 goes into 3 once, and it goes into 9 3 times. And then they say, well, what do I have left? Well, 1 plus 1 is 2 over 3. This is wrong. That does not work. When we cancel things down, what we need to do is divide everything in the numerator by a particular number and everything in the denominator by that number. So the problem is with that, we have this 1 here that we weren't dividing by 3. So if you can't divide every single number by 3, or by whatever common factor you're looking at, you can't cancel it off like that. Just like in this next fraction, 2 plus 4 over 6 would become 6 over 6, which is 1. But incorrect way of doing it is if you had 2 plus 4 over 6 and you said, well, I'll cancel off the 2 and the 6 here. So 2 goes into 2 once and it goes into 6 3 times. You can't do that because then that's told you that you've got 5 over 3, which does not equal 1, which is what it's meant to equal. If instead, with this, so that's wrong. If instead you took out a common factor on the top here of 2 and cancelled it, that would work. But it kind of looks funny when we're talking about it with just numbers here, because we can evaluate that quite easily. So what we're going to do instead is look at this with algebraic fractions. What we can't do is just cancel off things like this, like 1 and 2. No, does not work. And for the next one, you couldn't cancel off 2 and 2 here, or a 2 here and a 2 here. What we need to do instead, so again, does not work. What we're going to do instead is we're going to factorize. That then is taking out a number from everything in a numerator or denominator, depending on what kind of question we're looking at. So with this 5x plus 10, if we factorize this like we normally would, we'd take out a common factor of 5, and then we'd have x plus 2. See that how we've divided the 5x by 5 to give us this x effectively, and the 10 by 5 to give us this 2. Then we divide by that 20, and we say, okay, now I can cancel things out. So now I can say if I divide everything in the numerator by 5, that gets rid of this 5, and 5 divided by 5 is 1. That's what we're doing when we're cancelling, we're dividing. And we say, well, how many times does 5 go into 20? That's 4 times. So this gives us the correct answer of x plus 2 over 4. With this final fraction that we have here, we can't then continue cancelling because we don't have x as some multiple of 2. We can't divide x by 2. We'd have weird x over 2 in that numerator. So this is our final answer. We cannot cancel any further. I like to think of it as, like I mentioned before, everything's getting divided by a particular number. But I also like to think of it as I can only cancel things down when I have multiplication and division involved. If I have anything with an addition sign, it has to be safely trapped inside of a bracket. Now that might sound a little bit strange, and I agree with you. As we continue with these examples, you'll see what I mean. So what to do with the second one? We've got 2x plus 4. We're going to factorise first. So we get the 2, and then in brackets x plus 2 over 2. And now we can safely divide 2 by 2, which is 1, 2 by 2, which is 1. So we've cancelled off those 2's. We're left with x plus 2 over 1, which is just x plus 2. So what to do? What we noticed was we have to factorise first. Always factorise first. Now in some simpler examples, no factorisation is necessary. So let's have a look at these ones, just similar to questions that we've looked at in the past, A through to C. So when we look at it, we say, okay, what can we simplify down here? We've got 3 and 15. 3 goes into 3 once, goes into 15 3 times. So that gives us 5x over 1, which is just 5x. Remember, when you've cancelled everything off from a fraction, so for example, in this denominator, we'd cancelled everything off, you're left with a 1. Next one, we've got 12x over 4. 4 goes into 4 once, 12x 3 times. That's 3x over 1, which is just 3x. The next one, we've got negative 24x squared over 6. Looking at those numbers, I noticed that 6 goes into 6 once and it goes into 24 4 times. So that's negative 4x squared over 1, which is just negative 4x squared. Okay, that's the kind of simplification we've done in the past, but now we're on to some questions where we need to factorize first. Good rule of thumb is if you notice you've got any addition or subtraction signs, you need to safely contain them within a bracket before you can consider doing any cancellation. So let's do it here. We're going to factorize that numerator, so that's 2, and then in brackets x minus 2 over 8. So now we've safely contained any addition and subtraction signs inside of a set of brackets. We can now cancel off. So I notice 2 goes into 2 once, and it goes into 8 4 times. So that bracket has finished doing its job. Because there's a 1 there, 1 times whatever in that bracket is just x minus 2. If there was a number still outside of that bracket, we could have left it there. But we'd still need those brackets. So now that's x minus 2 over 4. Okay, the next one, we've got subtraction signs in both the numerator and the denominator, so we need to factorize first. So thinking about 12 and 18 in that numerator, the highest common factor, it's going to be 6. So 6, and then we're going to have in brackets 2 minus 3x, because the 6 times 2 gives us the 12 that we needed, and the 6 times negative 3x gives us the negative 18x that we needed. Okay, that was a good check. Then on the bottom, what can we take out? We've got 2x minus 3x squared. Only thing they have in common here is an x, so we can take that out. And now we've got 2 to give us the 2x that we needed, and we've got minus 3x to give us the minus 3x squared that we needed. And we're going to close up that bracket. Now, we've contained those subtraction signs inside of brackets. We can't cancel down anything here. We've just got 6 and x. But what we are allowed to do is cancel off entire brackets. So we've got a 2 minus 3x and a 2 minus 3x in brackets on both the numerator and denominator. You can cancel an entire set of brackets. What we're effectively doing is dividing the numerator and denominator by 2 minus 3x. So that means we've got 1 and 1. So numerator, we've got 6 times 1, which is 6, and denominator, we've got x times 1, which is just x. Okay, in the next example, I notice that things have already been put in brackets for us. And remember, we're allowed to cancel entire brackets, so we could cancel down this x minus 3 and x minus 3, 1 and 1. Notice we've also got that 6 and that 3, so 3 goes into 3 once, and it goes into 6 2 times. Can't do anything about that x plus 2 in brackets, so that's just going to remain there. So this becomes, on the numerator, all we had was this 2 in the end. So we've got 2, and in the denominator, we had 1 times x plus 2. That x plus 2 we could write here. Don't need the bracket anymore because it's just 1 in front of that bracket. 1 times x plus 2 in brackets is just x plus 2. Okay, let's continue on. So we're going to be factorizing what we've got here. We already did one with factorization, but let's do it again. So we've got 10 minus 5x in that numerator. We're just focusing on this for the moment. So factorizing that, we can take out a 5, and that becomes 2 minus x. And we've got to take out the highest common factor here. Highest common factor looking at that denominator is going to be 2, and that gives us 2 minus x again. This is quite lovely because we can cancel off entire brackets, and that leaves us with 5 over 2. You're perfectly fine leaving that as an improper fraction. Don't need to change it to a decimal or a mixed number. Now the next one, we've got x squared minus 9. Now if we're thinking about factorizing this, remember our process. We first said, is there a highest common factor we can take out? No, there's not. Next, is it a difference of perfect squares? It absolutely is. X squared minus 9 can be written as x plus 3, x minus 3. So we've nicely factorized that numerator now. Then we've got an x plus 3. Now it's not written in there, but these terms on the denominator we can imagine have a bracket around it for this purpose. When we're doing the entire thing, chuck a bracket around it. So we can now cancel off this x plus 3 and x plus 3. So that leaves us with x minus 3 over 1. We could have gone straight to x minus 3 here. Okay, so that's simplifying some algebraic fractions. We're now going to look at some multiplying algebraic fractions, and really this is using methods of simplifying just numerical fractions in the past. We can cancel in certain directions, so we could cancel like this, in this direction, or between numerator and denominator on either one. Only thing is we can't cancel in this direction, so we couldn't cancel off an A and an A here, for example. So there are a few ways you can go about these questions. You might like to cancel things down first, or you might like to multiply first. For example, you could cancel off a 2 here and do 4 divided by 2 here. And then you could multiply across the numerator. So a times a is a squared, or multiply across the denominator. 5 times 2 is 10. If you chose not to do that, method 2, so I'm going to write 1 for method 1, method 2, just multiply across. So 2a times a becomes 2a squared, and then 5 times 4 becomes 20. Then you can cancel. 2 goes into 2 once, and it goes into 20 10 times. So that simplifies down to a squared over 10. So you get the same answer either way. See which one you prefer. I tend to prefer to cancel things down first, because then I'm dealing with smaller numbers, but you can do it however you prefer. So this next one, we've got 8x over 7 times 5y over 12. I could cancel off, I know that 4 goes into 8 twice, and it goes into 12 3 times. Nothing more that we can simplify down here, so we're going to multiply across that numerator. So that's going to become 2x times 5y becomes 10xy, and then 7 times 3 is 21. So that's done. Let's look at the next one. We've got 4x over 9 times 3 over 2x. Quite a few things we can cancel here. 3 goes into 3 once, 9 3 times. Cancel off these x's. 2 goes into 2 once and into 4 twice. So on the top, we're left with 2 times 1, on the bottom 3 times 1, which you might have just gone straight to writing 2 over 3. Next one here. We've got this 3 goes into 3 once and 15 5 times. And I think that's all we can cancel. So what are we left with in the numerators? We've got 5 times 2, so that becomes 10. And on the denominators, we've got x times x, which is x squared. So this is a good moment to pause and remind you, when multiplying and dividing fractions, you do not need a common denominator. All fractions can be multiplied and divided with each other. So just remember, you're not trying to find a common denominator. Okay. Dividing algebraic fractions. We need to remember what we do when we divide by a fraction. So if I had a over b, for example, divided by c over d, when we're dividing by a fraction, this division sign is going to become multiplication. I'm just going to write out that first fraction again. And we flip this second fraction, so that becomes d over c. So we flip. When we're talking about a flipped fraction, this is properly called the reciprocal. So let's make a note. When we divide by a fraction, we change division to multiplication sign and write the reciprocal of the second fraction. So reciprocal, again, is that special word we use to represent when we have the flip of a fraction, or a fraction turned upside down. So that's the first thing I like to do. Always do the reciprocal or the flipping first before you start getting into it. So for example, we've got 2x over 3 divided by 3x over 5. Do not start cancelling yet. Your first action is to change the division sign to multiplication, and then 5 over 3x we have flipped. So it's up to you how you'd like to do this question now. You might decide that you like to cancel, or you might like to multiply the numerators and multiply the denominators. Let's multiply and have a look at what that looks like here. So 2x times 5 becomes 10x. 3 times 3x becomes 9x. We now have 10x over 9x, so those x's can cancel, and you can write your answer as 10 over 9. Improper fractions are fine. Next one, 6x over 7y is now going to be multiplied by the reciprocal of 2xy over 3, which is 3 over 2xy. I might decide that I want to do some simplification here. So I notice we've got an x and an x that we can get rid of. Anything else that we can do? There sure is. We've got a 2 goes into 2 once and into 6 3 times. So in the numerator, we're left with 3 times 3, which is 9. And in the denominator, we're left with 7y times 1 times y, which is going to be 7y squared. Oh, now this next one is going to combine. We've got some multiplication here rather than division, but we're going to be using our simplification that we talked about just earlier. So let's pop some brackets around this x plus 1, because that means we can go boom, boom. The x plus 1 is gone because it's been safely contained inside of a bracket. Notice we've also got an x here and an x here we can get rid of. So in that numerator now, we're left with 2 times x, which is 2x. And in the denominator, we're left with 3 times 1, because remember, when you've cancelled something off, a 1 is remaining there. So 3 times 1, which is just 3. So we're finished. So let's apply again. We've got 1 over x times x over 4. If we multiplied across those numerators, we'd get x over 4x, which we could cancel off those x's. We've cancelled off everything from the numerator, and that leaves a 1. And then in the denominator, we had 4 times 1, which is just 4. What you could have, of course, also done is cancelled off the x and the x here, which would have left a 1 and a 1, and then you would have had 1 over 1 times 1 over 4, which is also a quarter. Next one, we have division, so the very first thing we're going to do is we're going to deal with that. Write the first fraction, change the division sign to a multiplication, flip the second fraction. Over 6x squared. Now, I think it would be nice to cancel some things off here. I notice we have a 2x plus 1 and a 2x plus 1 in this numerator in the second fraction. We can cancel off this entire thing here. Then we've got a 3 and a 6. 3 goes into 6 twice and into 3 once. We have an x, which you could cancel off here, and one of the x's down here, x times x, cancel off one of them. So in the numerator, what are we left with? We had 1 times 4 times 1, so it's just 4. In the denominator, what did we have? We had 2 and x. Now, although I did some cancelling, I hadn't fully cancelled off things here. That's perfectly fine. If you notice that, we can cancel again. 2 goes into 2 once, it goes into 4 twice. So that means we're left with 2 over x. Okay, very last one. We've got some factorising to do. I notice we don't have a common factor we can take out here, but we have the difference of perfect squares, or DOPs, that we've talked about in the past. So I'm going to factorise that one now. Why not? X minus 3, I think I need a little more room, all over, and I'm going to write this x plus 3 in brackets here. Change the division to multiplication, then we've got 2x minus 6 over over x squared. So we've got an x plus 3 and an x plus 3 here that we can get rid of quite nicely. Then we've got, there's a few ways you could look at this next one actually. You could, well, we said we always want to factorise, so let's look at what we've got left. We've got x minus 3 over 1 here times, I've left that over 1 because we're going to be multiplying by a fraction. It's nice to have that numerator and denominator. Now this 2x minus 6, we could have factorised that to be 2 and then x minus 3 over x squared. Now unfortunately we can't cancel off that x minus 3, but because we've got it multiplied by itself, we've got x minus 3 times 2 times x minus 3. We have 2 lots of those x minus 3's multiplied with each other. So we could, in the numerator, now have 2 and then x minus 3 in brackets over x squared. If you'd expanded out those brackets and simplified it down, this year I'd also accept that. That would be perfectly fine. It's now your turn to have a go. Look at the independent practice questions 2.11 in your prime booklets.